Today we are going to learn about graph theory and its introduction basically. A graph G is represented as G equal to B of B and E, where B is a set of vertices and E is a set of edges. So in this case, B are the nodes. You can see that A, B, C, D are the nodes, and edges are A, B, A, C, A, D, B, D, C, D, B, E, D, which are connecting the vertices. So we have to look into certain terminologies of graph to understand what is actually graph is and what are the things that we can do with it. So vertex is basically an individual data element of a graph, and it is also known as the node. And edge is a connecting link between the two vertices. Edge is also known as an arc, and edge is represented as the starting vertex and the ending vertex. Undirected graph is a bidirectional edge. So basically a edge with no direction is basically undirected. Directed edge is a undirected unidirectional edge. So it contains a direction. So we put arrow marks to show the direction of a directed edge. Weighted edge is a edge with value cost or t. So if an edge has a value associated with it, we can call it as the weighted. Undirected graph is basically, it contains only undirected edges, and a directed graph only consists directed edges. So the total number of edges that are connected to a vertex can be called its degree. So for a undirected graph, the total number of edges which are connected to this any vertex is called its the vertex degree. In degree, for a directed graph, in degree is the total number of incoming edges connected to a vertex is said to the incoming degree. So number of edges that are ending at a certain vertex is the in degree of that vertex. And the opposite, that is out degree, that is the total number of outgoing edges connected to a vertex is said to the out degree of that vertex. So edges that are going out for a directed graph is called as out degree. So it's coming across. So in degree and out degree both comes to make the degree of the directed vertex. So this is an undirected graph. You can see that there are no directed edges. But in a directed graph, there are directed edges. So 2 points to 0, 0 points to 1, and 3 points to 2, again 1 and 2 points to each other. So that is the directed graph. Similarly, in the weighted graph, you see the edges are weighted. So 4 to 5 is weighted 3 and 5 to 4 is weighted 1. Disconnected graph, this is both are a graph, same graph, but they are disconnected. So that's why it's called a disconnected graph. How are graphs represented? That's a very important question. So either they can be represented as matrix or linked list. So left hand side is the matrix. So if we know the number of vertices, we can know the dimension of that matrix. So it is basically, if it is 5 vertices, it is then the matrix size is 5 into 5. The dimension is 5 into 5. And to know about the edges, we have to find the vertex, each vertex row by and column wise. So basically, if we see if there is a edge between 1 and 2, we go from 1 row wise, and from 2 we see that 1 and 2. So there is an edge between it, and yes, there is an edge between 1 and 2. But is there an edge between 2 and 0? So let's find 0, and we go from 2 to from here column wise, you see it is 0. So there are no edges in it. That's how the adjacency matrix works. Similarly, a graph can be represented as a linked list. We know about linked list, so it's an array of vertices. Each of the values points a linked list. So basically it points to the where it is connected to other nodes. So 0 is connected to 1 and 4. 1 is connected to 0, 4, 2, 3. 2 is connected to 1 and 3. 3 is connected to 1, 4, 2. 4 is connected to 3, 0, 1. So that is represented by an array of linked list. Array of lists. Traversal. So traversal, you know, that is visiting each and every node once. So there are two ways basically. There is a depth first search and there is a breadth first search. Depth first search is like a pre-order traversal only. So you visit the route and then you go then you select a branch and go as far as possible until you find no other nodes to be visited. Then you backtrack to see if there are any unvisited edges, unvisited nodes actually. And in the breadth first search, it goes level by level. So you search at that tree and you extract all its neighbor nodes, and then you select among the neighboring nodes one of the nodes, and you go to the next level. That's how the breadth first search works. Now let us look at the depth first search. So you see, it's like a pre-order, works like a pre-order only. That is root, left, and then right. So 1, then you visit 2, then you visit 4, then we backtrack. So we find 5 in here. So then again 5 we visited, then what is the unvisited is 3, then we visit 3. Similarly, in a depth first search, we go level by level. In this case, what you see, 0, then it visits 1, 2, and 3, then it selects 1, then it visits 4 and 5, then it visits backtracks and visits 2, then it visits 6 and 7. So basically it is 0, 1, 2, 3, then 4, 5, then 6, 7. That's why it goes level by level. So the visiting is like that. So this is your